Welcome to the world of data visualization when it comes to R. This function called plot does a variety of things. When it comes to your linear regression, plot has a different role to play altogether. And when it comes to your scatter plot or any other visualization, it has totally a different role to play. Now, whenever you use this function plot, it is x comma y if it's scatter diagram. So it's cylinders comma miles per gallon. The first variable would come on your x-axis and the second variable would be on your y-axis. So let me run this. There we go. So you have cylinder on x-axis and you have miles per gallon on y-axis. And but the moment we look at this, it's very easy to interpret that 4-cylinder vehicles have highest mileage in comparison to 8-cylinder vehicle. But when it comes to 6 and 8-cylinder vehicle, there is a lot of overlap which is happening, right? And there's a small overlap when it comes to your 4-cylinder vehicle and your 6-cylinder vehicle. So this is the kind of interpretation that we can draw using that. Okay. Now we are trying to plot cylinders and we are saying type equal to O. O stands for overlapping, right? The next plot that you're going to plot would overlap on this plot. In color equal to blue, and we are limiting the y-axis to 30. So let me run this. Look at that. Color is blue, all right. It's an overlapping plot. So we'll wait for, that. We'll wait for the next function so that you see on how overlapping happens. We're trying to plot this on cylinders, right? And 0 until you have 30, 31, 32. What are these 32? When it comes to your empty cars, you have 32 rows. So each index value represents one car. And you have y limit. So you have limited your y-axis from 0 until 30. So you can change the axis also based on your requirements. Now if I run this function called lines and try to come up with miles per gallon, type equal to O is overlap and color is red. So you'll see an overlap on top of that. Let me run this. There we go. All right. So now if I ask you to find out on what is the 8-cylinder vehicle which has the highest mileage, then you can spend some time on this and quickly interpret that. So look at this. These are your 4-cylinder vehicles, everything which falls on that line. These are your 6-cylinder vehicles. And these are your 8-cylinder vehicles. So we are interested in 8-cylinder vehicles which provides highest mileage. So maybe this red line represents the mileage basically, and blue one is cylinders. So this could be one data point. Let me see any other 8-cylinder vehicle which has the highest mileage. Okay, probably this could be one. And none. So let me try to draw a straight line in that way. So more or less these two vehicles have the same mileage. Probably this has better mileage, right? So it's 25th data point. Yeah, we can go back to the data set and also explore that. Let us do it. Here we go. It's 25th data point and we have 32, right? So this one, Pontiac Firebird, that has the highest mileage when it comes to your 8-cylinder vehicles. That's a good part. All right. Now box plot also does a lot of things basically. So let me show you how it works. We are trying to come up with a box plot for miles per gallon. Color equal to blue would give a blue color to your interquartile range. And if I say horizontal equal to true, box plot would be represented in a horizontal format. There we go. So you have this box plot which is in horizontal format. Box plot will help you identify the outliers, whether the data are skewed or not. And remember, it'd be like this if you try to overlap a probability plot. And wherever you have a peak, that would intersect or that would interact or to be exactly same as your median. All right. Seems like this data is also right skewed. Okay. Now you can add a lot of interesting arguments to your functions. For example, here we are doing a box plot, but we are just adding miles per gallon tilde cylinders. This is Y tilde X, right? And you have data which is empty cars. We want a main heading which is car mileage data. We want an X label for X-axis, and we want a label for Y-axis. So let me run this. There we go. So we have 3 box plots. And do we have an outlier in this data? Oh yeah, absolutely, I have an outlier here. And how is the data skewed? It is right skewed. This one seems to be left skewed. This one seems to be right skewed. Because like that. That way. Right. Just think about drawing that probability plot and then you get a sense. Yeah, because there is, this length is bigger than this one. Here also this length is bigger, and here also this length is bigger. All right. Pie chart is considered to be one of the worst charts to be ever used in management. You can refer to Tableau tutorials and you'll find out on why pie charts are the least preferred. But you might ask me this question on, then why are you explaining us this? All right, I'm explaining you all this because there is one such function. So let us do this. Stars, empty cars, and we want to draw the segments, and this key dot location would just place all these data points in a specific format. That's for the formatting basically. Okay. So if you look at this, it's very clumsy, number one. Not many insights that you can draw, right? But the only thing that you know is what represents what. And maybe I'm sensing that, you know, the number of cylinders for Mercedes-Benz 450 SLC and your 230 and 280 are the same, maybe. But it's, and 450 AC also. But it's making my life very difficult, right? So just because this kind of a visualization is available, I'm trying to show you, but I'm not sure on what analysis we can perform based on this data. R is extremely good at data visualization, which we'll understand now. There is an inbuilt dataset called IRIS dataset, which is extensively used for data mining purpose. This IRIS dataset gives the measurements in centimeters of the variables such as sepal length, sepal width, petal length, and petal width. Yep. So you have 50 flowers and 3 species of iris. And you have these 3 species: Setosa, versicolor, virginica. You have 3 species basically, right? And if you do data of iris, you'll be loading the data and you'll be able to access this data from here on. If you say view of data, you'd be able to see this. So you have sepal length, width, petal length, and width, and you have the corresponding species. And we have 3 species there. If you do plot of iris, it is going to give you a scatter diagram. You'll be able to look at the scatter diagram for each and every variable that is available. Right, so look at this. For example, the correlation between sepal length and petal length is positive. If you look at the correlation between petal length and petal width, that is also positive. So in this way, you'll be able to make out some sense, right? And you can either look at, if I cut along the diagonal, you can either look at the upper triangle or the lower triangle. And one more thing here is, you also get to see that there are two broad clusters. And here also you have two clusters. You have one cluster here and another here. Yeah. So in this way, you can also identify the clusters, and briefly, you will be able to understand on the strength of the correlation basically. Okay. You can do a head of iris. If you do head of iris, you'd be able to see the first 6 entries of this data set iris. If you do tail of iris, you'd be able to see the last 6 entries of iris data set. Okay, and here we go. Plot sepal length and iris. Look at this. This is expected to be very interesting. If I plot it in this way, you get this kind of a plot, kind of a scatter plot. You have the sepal length and species, and the moment you look at that, you know for a fact that the sepal length for the first species is very less in comparison to the other species. But if I just swap these two positions, species and length, it would altogether come up with a box plot for you. I'm using the same function called plot. If x is this, always it is plot of x comma y. Here, if x is continuous, and y is discrete, if this is the case, then what kind of a plot would you get? You would get some kind of a scatter plot. However, if this x happens to be discrete, and y is, say, continuous. If x is discrete and y is continuous, and then when you try to plot, you would get a box plot. And here there is an outlier for Virginica, right? But otherwise you get a box plot. If you just use a single variable and try to plot, you get some kind of a run chart, and index here is a value for each and every flower. So you have the sepal length for first flower, second, third, fourth, fifth, probably sixth, seventh, eighth, so on and so forth, right? So you have how many data points here? 150. It starts from 1 until 150, right? So if you just look at this data set, you have 150 entries, and you have 150 entries there. It's kind of a run chart, that's it. Now, another plot that might impress you to know the distribution, of course, to know the distribution of the data, is stem and leaf plot. For that, the function is stem. And there we go. So let me open the iris dataset. and we are trying to plot for sepal length. So let me sort by sepal length. So 4.2 and 4.3 is included in this. And how many entries do you have? Only one entry. So you have 1 0 there. So the decimal point is 1 digit to the left of this. So 1 digit to the left of this. So it should be 4 point something. Okay. Now 44. 44 includes 4.4 and 4.5. How many entries do you have for 4.4 and 5? You have 1, 2, 3, and 4. Let us see whether there is anything else. No. Right? So you have 4 entries. Hence you have 4 zeros there. And when it comes to .6 and 4.7, let us see. So this value here represents both 4.6 and 4.7. And 4.6 and 4.7, we have 1, 2, 3, 4, 5, 6 entries. And we have 6 zeros here. In that way, data is represented here. What kind of sense can I make using this? Imagine this in horizontal format and try to connect the peaks of all of these. Roughly, I get a sense that if you don't draw it in that way, still I roughly get a sense that this is one cluster and this happens to be another cluster. Yeah, there are two groups. So there are two modes in the data. It's similar to a histogram or a box plot or a stem and leaf plot. All mean the same. I mean, all will give you similar kind of inference basically. Yeah, it's kind of multimodal, exactly. So this is the kind of analysis that we can perform when it comes to stem and leaf plot. Okay, write.csv, we know that that's a function to write any CSV file into R. And in the next tutorial, I'll also touch upon how to read different formats of files into R and how to write the different formats of files to your computer. We'll briefly touch upon that. So anyway, since we have this, I'll explain this. Write.csv of iris, file equal to iris.csv. This would save this iris data set to iris.csv. Okay. And now if you want to know on where you have stored this, you have to check your working directory, get working directory. Use this in this. If I go there, so in this way, any inbuilt data set, yeah, you will be able to store it to your computer using these functions. Iris, there we go. We have it here. All right. Set working directory, you can set your own working directory. We have, I think, discussed that already.